Morning everybody. Today we are discussing the next topic of the electrochemistry, that is the thermodynamics of the cell reaction. And in this part we are explaining the relationship between the Gibbs energy change and electrical energy and what are the application of the Gibbs-Helmholtz equation according to the cell reaction. So we know that the general equation electrical energy is equal to quantity of the electricity passed through the cell into EMF of the cell. So according to the thermodynamics, Gibbs energy is the amount of the energy which is taken out from any system. So in the case of the battery or any cell, the free energy means or the energy which is taken out from the useful energy which is taken out from the battery is the Gibbs energy. So how we will find out that the amount of the energy which is taken out from a cell? We know that the EMF of the cell, we can easily calculate the EMF of the cell, but how we will relate the EMF to the other thermodynamic function, say for example delta G and delta H and delta S. So for that, according to the electrochemistry, we know that the quantity of the electricity which is passed through the cell for the transference of 1 mole of the electron, that's equal to 1 Faraday. So you know that we cannot limit the cell reaction within a 1 mole. Okay, so that's why for a general cell reaction, the quantity of the electricity passed through the cell for the cell reaction having the n mole of electron, that's equal to NF. So the above equation can be rewrite as electrical energy is equal to quantity of electricity passed is equal to NF and EMF is represented by E. So electrical energy is equal to NFE. So as I told you above, the Gibbs free energy means it is the amount of the energy which is taken out from any system. So for the case of a cell, the total energy which can be used for the other purpose, or for the amount of the energy which is taken out from a battery is the electrical energy. So if you correlating the thermodynamics, the electrical energy is equal to Gibbs free energy, that is the amount of the energy which is taken out from the battery. So we can replace the electrical energy by delta G. And we know that for a thermodynamic system, for a feasible reaction, delta G is always negative. That's why for a reversible cell, delta G is represented by negative. So minus delta G is equal to NF into E. Then according to the thermodynamics, we know that delta G is equal to delta H plus T delta S. And if you are substituting the delta S in terms of G, we can substitute delta S is equal to dou delta G divided by dou T at constant pressure. Then as we discussed earlier, delta G can be substituted by minus NF into E, that's equal to delta H plus T into dou. Instead of G, we can substitute minus NFE divided by dou T at constant pressure. So if you are multiplying the both sideways with minus, so we will get NFE is equal to minus delta H plus NFT into dou delta G divided by dou T at constant pressure.